Hello and welcome to Tea Leaves Programming. Today we are doing Haskell for Dilettantes. We're moving on to problem set 11b from Joel Kaasinen's massively online course at haskell.mooc.fi. So what is set 11b? It seems like it's mostly about monads and mutable state. Now you might say, do we really have mutable state in Haskell? And the answer is yes, of course we do. Now it is true that the syntax of Haskell kind of guides people to using what we call pure functions, but that doesn't mean that impurity is impossible. If you had a language where the only operations you could do were pure, then you would have a programming language which would accomplish nothing except heating up your computer. At some point, you have to communicate what you've computed to the outside world or get input from the outside world, and those operations are inherently impure. This, by the way, raises something that I feel really strong about, and it's that the words pure and impure, when used in kind of a programming context, they're terrible words. They are problematic words. In English, I'm not going to speak for other languages, but in English, pure has a positive connotation and impure has a negative connotation. And it is crazy pants bull moose loony to walk away with the idea that pure computations are somehow generally better than impure computations. It's not true. The reason we sometimes like pure computations is because they're easier to reason about. And if you're writing a complicated program, that can be a virtue. It does not mean that they're better in all cases. And I think the words pure and impure lead people to this completely incorrect conclusion that purity at all costs is something we should be seeking. I prefer to call these computations with side effects and without side effects. Instead of saying this is a pure function, say this function has no side effects. Instead of saying this is an impure function, say this function has a side effect. You know what? A lot of times the side effects are the things we want. Okay, with that said, let's jump in to set 11b. Exercise 1. Given an IOREF string and a list of strings, update the value in the IOREF by appending to it all the strings in the list in order. By appending. Okay, so we're not appending to the strings. We're appending to the IOREF. That's a little hard to read. Let's look at our example. Given some IOREF that contains X, we should know what is an IOREF. That is not an IO, that is an IOREF. And if you read chapter 11, as you should, you will learn that IOREF is a type that helps you manage mutable state. So in this case, we're being given an IOREF, right? Let me look at the code again. Yeah, that IOREF is being given to us, so we don't have to create one. And we have something that we could create from a pure function. We're going to create that foobar kooks, I like that word, kooks, out of a list that contains foo and bar and kooks. So that could be a pure function. That could be concat. So we're probably going to use modify IOREF. What's the type signature there? In fact, let me copy that type signature just so that I have it over here. Okay. All right, so we're being given some IOREF, and we're being given a list. And what we want to return is the modified IOREF. So we should bind that to something, shouldn't we? And then we need to say what we're going to be applying to it, which is going to be concat, not contact. Is that right? Well, obviously something's wrong here. Oh, because I need a do, right? This all needs to be inside a do block. And I need to be, because this is creating another list, but I actually need to be appending it here. This needs to be a pure function. I think we could do that. Do I need to be binding this way, or can I just think I could just do that. No, why not? Because this doesn't actually modify IOREF. Oh, because return is going to lift it. Actually, we could just do that, right? We don't need to explicitly return at all. I got to tell you, this is the thing that confuses me a little bit. I know return is just a type system thing, but I always get that a little bit confused. Let me save that. In fact, if we do this, right, we didn't need to lift the result here because the result is an IO unit. And so by slapping a return on it, we're actually lifting it again into IO unit, which is not what we want. Let's run our tests. Set11b test.hs. Great, that's exercise 1. Now, as always, I'm not going to be putting all of the exercises for this chapter in the video. I'm going to do them all here and then edit it up, and I'll take, 3 or 4 of them and put them in. That way you can do the rest yourself. I really don't want people using this as some sort of resource to cheat for the class. I want you to use it as a resource to think about what we're doing here. Given an IO of A, return an IO of A. So this one's interesting because we're working fully in abstract types. This isn't a string or an int or anything. So let's use do syntax here. This is one where I think trying to desugar it and use lambdas would rapidly get very unreadable. We've got this operation, and this op is an IO of A. So if we this should now be an IO of A, and we can run that. And now this should be A, which we're just going to return. Do I actually need to be doing that? Yeah. Yes, the reason I think I have to do this, I think I can't just return outer, right? Let's try it. I think this is wrong. And the reason it's wrong is that we haven't actually run that operation, right? This is IOA, and then we're returning it. Can I just do that? Right. And in fact, I'm naming these wrong. Naming, one of the hardest things. This is our kind of wrapper. This is the thing inside it. And then this is what we're actually returning. I think the thing I was doing earlier where I had outer and inner, binding it twice, that would have worked, but it was unnecessary work. That's exercise 3. Composition for IO operations. So this is of type A to IOB, this is of type C to IOA, and this is just a C. This is one that you could get yourself confused on, but it's actually very simple. You're just playing type hole golf. We'll use a do. We have a C and we have a function that takes a C. So that's, I'm going to use more parentheses than I need to. Op to C, let's bind that, and that is going to return an IOA. Which, since we're binding, it's just temporarily going to be an A, essentially. That's how I think of it anyway. Although this yields an IOA, we kind of have an IOA right here. That is IOA, but then we're binding the A to that name. And if we have an A, we could feed that to op1, which is op1A. And that's it. That's our answer. So now we're actually getting into something that is not abstract, reading lines from a file. As they say, we can do this a bunch of different ways. I am going to use this function, which takes a string and returns a list of strings. So they give us a number of functions here. The most important one right away is this hGetContents. That's what I'm going to use. Reads the content from handle until the end of the file. So it takes a handle and it returns an IO string. So we're going to say we've got some handle F. We're going to say hGetContents F, and that we'll bind that to something called file. And so file now should be an IO string. Yes. And what I want to return is an IO list of strings. And we can use the list function. I think it's a list function. String function. Finds file. Right, I should never return it, I think. Let's see if that works. It does. I feel like this is one, they even warn you, there's like a bunch of different ways to do this. And I'm a big believer in what we call wholemeal programming. If you have a function that can hide the abstractions from you, use it. You know, you could get really down in the weeds here about doing all the things that is going to do for you. Just use it. Oh, so this one is fun. It's basically eval. You're going to be interact. You're going to read a line from the user, feed the line to F. F returns a Boolean, a string to print, and a new state. And they've given us a little state machine here that we are not supposed to change. So we can see that inc followed by some number is going to, or whatever was previously fed in, is going to increment it. Print is going to print it. And quit is going to quit. They're kind of implementing a really basic version of the state monad, aren't they? We've got st is our current state, and then we're going to return the state modified by. All right. So we definitely need to be getting the input from the user. The user's going to type something no matter what. And in fact, that's the first thing that's going to happen is the user's going to type something. And so we have a function for that, just getLine. This is a function that goes from string. So string here is user input. The popovers are not helping me here. I want it to be telling me the type of getLine, and it is not. And we can see we have this function here that goes from the string to the state to a bool, a string, a state. So this is F, and we want to feed in, essentially, user input and the state. And that's going to give us, but this is all happening inside the IO monad because we had to bind from getLine. So we're still going to be in a bound context. We're going to get back a result. What is the new thing? It might print something. So we'll just call that output and call that new state. No, this shouldn't be bound because this is not returning an IO anything, so I'm just deranged. It's just a let binding. Right, and now it's happily no longer complaining. This will actually be new state, I think. But we're not done, because we still haven't printed the output. So what would happen if we tried this now? What happened was, we did the first bit of this. Right, this actually makes sense. Because we never go back into interact. We print the output and we return the state, which is exactly what you could see is happening here. It expected a bunch of operations, and we only returned one operation. If the Boolean is false, the execution has ended and the state should be returned. So if the Boolean is not false, if result, then something else, return new state. And so I think we're just going to call back into interact with our new state, which is going to be, it's the same function, f, new state. I think that feels right. Nice. Well, that's set 11b of the MOOC at haskell.mooc.fi. This is a fun one. This is getting a little more complicated. I'm uncertain how much of the complication is because I don't feel fully comfortable with IOREF as a type because I haven't used it a lot before. But clearly, I mean, the signal I'm getting is that I'm going to have to get good at managing this cognitive understanding of like, when am I inside? When do I want to get something out of the monad versus when am I not operating in a monadic context? And we can see here, that's going to be mixed around very often. And so it feels to me like that may be the big challenge going forward. We'll see how I juggle it. You've been watching Tea Leaves Programming. We're programming like it's 1979. The name of this series is Haskell for Dilettantes. Thanks for watching.